If f of x is the integral from 0 to x of that function, find f double prime of x. Well, what are we gonna how are we gonna do this? Well, our first step is to take the derivative, f single prime. So what's gonna happen? I'm basically gonna take the derivative of this side and the derivative of that side. Now, rather than write dir, which is kind of dumb, I'm gonna go d dx, d dx. That's the derivative of respect to, or you can do a prime, whatever. What's going to happen on the right side? The derivative cancels out the integral, right? That's the fundamental theorem of calculus, which is what this section is all about. In the 1500s, I believe it was around the same time, Newton and Leibniz discovered that the derivative and the integral were opposites of each other. That was a huge, there's only one fundamental theorem in all of calculus. That's the most important idea in calculus. The derivative and the integral are opposites. People were doing derivatives for decades. People were doing integrals for decades. They just didn't realize they were the opposites. That was the big discovery. The fundamental theorem of calculus. Derivative cancels integral, they're opposites. And by the way, this part cancels too because that's part of the integral stuff. It's just all part of the symbolism. And then you just plug in the x everywhere to your function. Just take that x and plug it in. So what do you get? You get x cubed plus 6x squared plus 2. So it changes from t to x. Why? Because we're integrating up to x. And this number here doesn't matter what. It could have been 0, could have been 10 million, whatever. Just take that x on the top, plug it in because the derivative canceled the integral. Now that's the first derivative. Okay, but now we need another derivative because they're asking us for the second derivative. So now what are we going to do? Well, we're going to take the derivative again. So you know how to do this. It's just there's no more integral there now. You see the difference? This will just be, that was a funny looking 3, wasn't it? It's just going to be 3x squared. Still looks kind of funny. It's 2, subtract 1 from the power. Bring the 2 down, 12x to the first, right? Subtract 1 from the power, and that'll just go away. And there's our answer, 3x squared plus 12x, 3x squared plus 12x. So the first derivative canceled out the integral, so the function didn't really change. We just plugged in x. Then second derivative, there was no more integral to block the derivative, so we had to actually do the derivative of the three pieces. And so there we go.